Okay, till this lecture we have learned fundamentals of linked list, and from now on we will look at operations that we can perform on linked list, which includes creation, insertion, traversal, searching and deletion. In this lecture we will start to perform these operations on single linked list. Then we will continue to other three types of linked list. So let's look at how can we create a single linked list. There are a few steps to create a single linked list. First, we create a blank head reference and then we create a blank tail reference. Then we initialize both of them with null. So we know from the previous lectures that the head always points to the first node and the tail always points to the last node. Right now we don't have any node to be pointed. That's why the reference of head is null and the reference of tail is null in this first step. So the next step is we create a blank node. So here first we are initializing the reference part of the node with null, indicating that there is no other node in the list. And finally we are initializing the data part of the node. So let's say in this case the node's data is 1. So as we created this node, the node's value will be 1. So the data in node is 1. So let's say that physical location of this node in the memory is 111. So as you see in the second step we are creating a blank node and assigning a value to it, and the next reference of this node is always set to null because in this case we don't have any other node in our linked list. So then we are going to continue to the next step. So in the next step we are going to reference head to this node and tail to this node over here. Because in this case we have only one node in our linked list, so this means that updating the reference of head to 111 is going to reference to this node over here. So as you see, when we update it, the reference of head is changed, so now it's referencing to this node over here. So we know that tail also has to reference to the last node, so in this case we have only one node in our single linked list. That's why tail also will reference to the same node over here. This means that tail reference will be updated to 111, so this creates a link between tail and this node over here. As you can see, there are three steps to create a single linked list. In step 1, we create head and tail with null references. In step 2, we create node with reference null and initialize the data to it. And in step 3, we are linking head and tail to this node that we created over here. So this is how we are creating a single linked list in which we have only one node. So based on this logic, let's switch to Java and implement this logic in practice. So here we are going to have three different classes. So the first class is main class, then the second class will be node class, and the third class will be single linked list class. So in which we are going to implement all operations in this single linked list class. So as we said in our first step, we need to create head and tail references. But before creating the head and tail references, I need to have a class in which we will have all node properties. So that's why before continuing to the first step, I'm going to create a node class over here in which we will have a value and next reference. So we know that in case of linked list, in node we have two properties. The first property is value and the second property is reference to the next node. So in this case I'm going to create our class like this. Public class node in which we will have two properties. So the first property is public value. So in this case you can select whichever data type you want. For simplicity I'm going to select the integer type. So in this case our single linked list will store all the integer numbers. So the first property is value and the second property will be next reference. Now you might be interested what will be the type of next reference. So the type of next reference will be node because this reference points to the next node. So in this case it's going to be type of node that we created over here, this class. Now after creating our node class, we are going to continue to implement our single linked list class over here. So I'm going to create our class like this, public class single linked list. So inside this class, I'm going to implement all operations that are belong to single linked list. So as we said, our first step is we need to create head and tail. So in this single linked list class, the first properties that we will have will be the head and tail properties. So I'm going to create our head and tail properties like this. So head and tail properties will be the type of node that we created in the node class, and here the second property will be tail. So this one also will be the type of node because both head and tail will point to the node, so that's why the type of them should be node. Now here I'm going to implement another property which makes our life easier for some transactions in the future, so I'm going to implement it right now. So this will be public int size. So every time whenever we add a node to this single linked list over here, we are going to increase this size over here, because with this way we will know how many nodes we have in our single linked list. Now inside this single linked list class, I'm going to create our first method, which will be responsible for creating single linked list. So the method will be public. So as a return, it's going to return the node, because when we are creating single linked list class, we will always return the head reference. So that's why head is the type of node. So that's why it should return the type of node over here. So I will declare it create single linked list. Then as a parameter, it's going to take integer, because as we said, our node value is integer. So that's why the parameter over here will be the value of node. So that's why it's going to be integer. So I'm going to put it like this, node value. So with this, we can understand that this value over here will be the value of node. So inside this method, we are going to implement our first step. So here, the first thing that I'm going to do, I will initialize head with the type of node. So then I'm going to create an instance of this node class over here. So it's going to be like this, node equals to new node. Then after doing so, we are going to set the next reference of this node to null, because in this case we have only one node in our linked list. So the next reference will be null. So I'm going to set it to null. And the value of this node will be set to the value that we are getting from this parameter over here. So node value will equal to node value over here that comes from the parameter. Then we are going to reference head and tail to this node over here. So head equals to node and tail equals to node. With this, we are setting the reference of head and tail to this node over here. Then at the end, we are going to set the size 1, because in this case we have only one node in our single linked list. So this means that the size of single linked list is 1. Now at the end, as we said before, we are going to return the head reference. So return value will be head. So with this, we have completed creating of single linked list method. So by using this method, we can create a single linked list in which we will have one node. So inside main class over here, I am going to create our first single linked list. So this means that inside main class, we are going to write something like this. The first thing that I'm going to do, I'm going to create an instance of single linked list. So single linked list. So I will put SLL equals new single linked list. Then we are going to call the method of single linked list class, which is creating single linked list. So create single linked list. Now in this case, for node value, I'm going to put 5. Now if we run our code, you'll see that our code runs successfully, but we cannot see that if our linked list is created or not. So how can we check that if linked list is created or not? So if we just print out the value of head, we can see that if it is 5, then in this case it's successfully created. So what I'm going to do, I will just print to the console system out print. So I'm going to print out to the console the value of head. So in this case, we have created our single linked list like this. So I will access head and value. Now one more time, if you run our code, you will see that it's going to print out the value of the node that we created over here. So we know that the value of node is 5. So as you see, our code printed out to the console 5. So this means that our single linked list is successfully created. Now let's look at what's the time complexity for creating of single linked list. Now as always, we are going to look at our method over here. So this is our creation of single linked list method. So we will start from the first line of code. So in the first line of code, we are initializing head. So initializing head using node class takes O1 time complexity. Then we are creating an instance of node class with node. So this means that it will take O1 time complexity. Then we are setting the next reference of this node to null, and this is also takes O1 time complexity. Then we are setting the value of this node, the value that comes from the parameter, and this one also will take O1 time complexity. Then we are setting head and tail to this node over here. So we are referencing head and tail to this node. So this one also will take O1 time complexity. At the end, we are setting the size 1 and returning head. So this two line of code also will take O1 time complexity. Now if we combine all these complexities over here, we will get O1 time complexity. So this means that creating a single linked list takes O1 time complexity. Now the space complexity is also O1 because in this case we are only creating one node in the memory. So that's why it takes O1 space complexity. So with this we have come to the end of this lecture. So hopefully everything is clear about how to create single linked list in Java. So see you in the next lecture.